Hey guys, meteorologist Lindsey Slater here. I try to do these every Monday, and then it's not a habit just yet. Plus, the sun, it's been giving us some solar flares, even a little bit of radiation storms, but we haven't seen many CMEs until yesterday. We did see one CME that went off. We have a coronal hole right there. This is basically open magnetic field lines kind of pointed towards Earth. This is definitely Earth directed. So we are getting some fast solar wind out of this that can allow for some storming. Basically, what happens when solar wind and CMEs or coronal mass ejections, when they are towards Earth, Earth has a magnetic field. I'm going to show a picture of Earth's magnetosphere. Hang on one second. Earth's magnetic field. There we go. I mean, this is a very generalized view of what it looks like here, but it's kind of looks like this. It's got these little lines like L shells all around the Earth. And what happens is when these systems or these the coronal holes and this fast solar wind or coronal mass ejections shoot plasma towards us from the sun, and you can see the sun, whoops, you can see the sun right over here. When that happens, it allows these to kind of move back and forth. So you can see why there's a lot more of a likelihood of auroras happening at the poles, because all of these lines, all of these magnetic field lines go right into the poles, which is why when things start storming and things start acting up, they reverberate and go right to the poles. What happens when they start getting really stormy is they move, they wiggle, and it allows for that shell around the Earth to kind of change where it is. That is how we can get auroras in some areas that are further south. Again, more likely near the poles, but that's just, again, a very general, it's not the most beautiful view I've seen of the magnetic field. I'm actually going to find, maybe I can find a better one. There is so many better versions of this. This is a good one. This one's from NASA. I should have shown this in the beginning. See those little shells? So most of them and all of them kind of go towards the poles, but sometimes you can interact the solar wind fields, and you can interact with the CMEs, and it shakes these to the point where these lines kind of dip. And that is what we're seeing when we have auroras around here. Also, when that happens, you can also really impact due to the plasma, due to solar flares that will cause radio blackouts. That's not going to cause auroras, okay? You can have solar energetic particle events. Now, those are more for astronauts. So when the sun launches something and you see all these little particles come out of it, that is when you have issues. If there's astronauts in space or satellites that can interact with that, you can get radiation poisoning from that. Then when we get these coronal mass ejections, that is when we get plasma coming out of the sun, and that interacts with Earth's magnetic field to give us these beautiful aurora displays. It also can give us a lot of arcing, basically, of the energy. And what that does is that it plays to like transformers in our electrical grid, which becomes a problem. There has been many instances where there have been blackouts in entire countries because of solar events. So that's why I like to kind of give you this base behind the science of solar events. All right, so now we're looking at the helio viewer, which is showcasing not particularly active. There's lots of flaring regions. I can go and show I believe it's the 193. No, yeah, it's 131. I always mess that one up. This kind of showcases where we do have these active regions with flaring. 171 kind of, you can really see those beautiful arcades here. And what we're looking at, basically, you see these little arcs right there. This is where you have the connecting pieces of those sunspots, and eventually they launch plasma. Once it's too much, basically, it launches that plasma. So we're seeing that if I zoom in. You can even see kind of like this railroad track feature, which I learned from Millersville University from Dr. Tamitha Scove. So here you have an open field line. You have that flaring region going out. So this is look how wide that is right here. Wow. That is honestly, that is pretty cool. I believe that's a filament. I always screw up prominence and filaments. I believe this is a prominence is when it's like, I always screw these up, so I apologize in advance. This one's getting ready to launch, so that would be one to watch as well. And then you have some other regions here and here that look like they could be launching pretty soon. 211 shows us coronal holes. If you notice, if I go to a different view here, you can barely see it. And then we go to 211, boom, coronal hole right in the middle of the sun. All right, so let's take a look at what SWPC is saying, and they're talking about that exact region I was just mentioning, very active region. So we're looking at the potential of some radio blackouts. If you go to their homepage, I believe we did have an R1, which is a minor radio blackout. They are forecasting a G1 prediction by the 6th. Basically, I think we get like a glancing blow out of this CME that was launched recently, and it's enough to maybe perturb a few things. So I will keep an eye on that. But here's what I want you to watch right here. You can see, and right there. Wow. That's actually pretty incredible. Looks like even an SEP event there. That's radiation coming out of there. So right, this region here is very active. Let's watch it again. I'll zoom in a little bit. Oops, I went too far. Went too far, everyone. I apologize. Let's do this again right here. And I mean, the brightness, I mean, it's just pretty amazing. I think that's pretty awesome. As far as any of these, we did have some M-class flares launch associated with some of this activity. No SEP events coming out of that. I mean, that's a possibility with that CME. You see the energetic particles did jump as a result of that. The K index stayed, again, this is an average of 3 hours, pretty low actually. It did kind of get up to about 5 there for a little bit, but nothing that would make me feel like we need to worry about the aurora. And the reason I'm saying that is because I want to show you Enlil, which is the space weather model that kind of highlights the direction of that CME. So watch this. Here's the 3rd, and you're going to see the launch. There it is, right there. It is moving the wrong direction, following fast solar wind. You see how it kind of broke up there? It's following that fast solar wind where that coronal hole is. So I would say we get in on some of that fast solar wind, but at the same time, that may be a reason we get some minor aurora. I mean, we're on this like phalange right here where we can see a little like a glancing blow from it that would likely be arriving possibly on the 6th or maybe 7th of November. But otherwise, that is your space weather news of the day. There's something else I wanted to highlight. So you guys have a great one, and I'll see you next week for more space weather updates.